Hey guys, welcome back to my YouTube channel. My name is Bhanu Chandra and I'm studying in Sri Venkateshwara College of Engineering. I'm a second year student into engineering and this is my video assignment. My USN is 1VE23CT007 and my branch is Computer Science Engineering with specialization of data science. So the today's subject is operating system. The subject code is BCS303 and today's topic is concept of multi-threading in operating system. So let's get introduction. So what is multi-threading? Multi-threading allows a process to have multiple threads of execution within a shared memory space. So consider a very long program which has been multiple code lines and which is very difficult to understand. That whole code can be broken down into simpler threads and executed individually. So these individual threads are stored in the same memory space. So extra memory is not created. So why is it important? This enables multitasking and efficient CPU utilization. So since there are multiple threads, even if one thread is not working, others will work properly. So CPU idle time is reduced. It supports responsiveness and in interactive applications. So if we are using interactive applications, the response time is very low. Example of multi-threading system is web browser handling multiple tabs. We open our web browser and we use different tabs at the same time. Server processing multiple requests simultaneously. So here, what is a thread? So definition of thread is given here. A thread is the smallest unit of CPU utilization within a process. It consists of a thread ID, a program counter, a stack, and a set of registers. So characteristics of thread is it shared resource like memory, file, and variable, and it operates immediately on other threads. So multi-threading models. There are two types of threads to be managed in this multi-threading modern system. So first one is user thread and second one is kernel thread. So user thread are the thread that application programs would put into their program. They are supported above the kernel without kernel support. So kernel threads are supported with the kernel of OS itself. All the modern OS support kernel level threads allows the kernel to perform multiple tasks simultaneously. So in multi-threading models, there are three types, and each type, these user thread and kernel thread are manipulated differently. So in these multi-threading models, in specific implementation, the user thread is mapped to the kernel thread using one of the following models. These are the three models. And first one is many to one model. Second one is one to one model. Last one is many to many model. So many to one model. In this many to one model, many user threads are mapped to a single kernel thread. As you can see here, these are the user threads. These are the user threads here. These are mapped to a single kernel thread. So advantage of this use many to one model is it is very simple to understand as only one kernel thread is involved, and if there is any defect, the kernel thread is inspected. Disadvantages is single thread blocking stops all the threads. So if there is one thread is entering the kernel thread, another thread has to enter the same kernel thread at the same time. It provides a hindrance. So the second type is one-to-one model. In this one-to-one model, it creates a separate kernel thread to handle each user thread. So as you can see in this picture, so these are the user threads and these are the kernel threads, and each user thread is mapped to only single kernel thread. And this kernel thread cannot have two user threads. So advantage of this one-to-one model is true concurrency. So many tasks can be done concurrently, one behind the other. So disadvantages: high resource consumption. So many resources are required at a single time to process one data. So the last one is many to many model. In this many to many model, multiplexes many number of user threads into a equal or smaller number of kernel threads. So this is the best combination of one to one and many to one model. So as you can see in this picture, so some number of user threads are mapped to less or equal number of kernel threads here. So advantages of having this many-to-many model is this combines the benefit of both one-to-one and many-to-one model. So disadvantages, the flow of control cannot be monitored easily. So so moving on to benefits of multi-threading. So these are some benefits of multi-threading. So first one is parallelism, perform multiple tasks simultaneously. So when we are doing some job on our PC, if we are running one application, we can run many multiple applications in the background. Um, Second one is responsiveness. Keep application responsive. Example UI updates. So if we are running one application and there's another application running behind the screen in the background, so if we want to access that, it is responsive. So efficient resource utilization makes better use of CPU cores. Since multiple threads are used, if even one is defective, others are running, so there is no idle time of the CPU. So efficient resource utilization is done. So moving on to the real world applications of multi-threading. So here are some real world application of multi-threading listed here based on the aspects of the use. So first one is operating system, efficient task scheduling in Linux and Windows. So multi-threading is used for scheduling algorithm in Linux and Windows OS. So web browsers, it handles multiple tasks and background processes as we know. For example, we use Chrome. In that, we can work with multiple tabs at the same time. We can manipulate data. Third one is gaming. So parallel processing of AI, render, and physics. So we know popular games like Minecraft and Valorant. So there is render distance in that only the player can see only till a certain distance. So that is done using multi-threading. Last one is server, concurrent handling of multiple client requests. So in client and server program, if there is hindrance at any part of the program, it is very difficult for the transfer of data. So multi-threading acts there. So today's conclusion is multi-threading improves performance and responsiveness and efficiency. Some challenges that include synchronization, deadlocks, and debugging. So we can improve the quality of programming using multi-threading. So that's it for today's video. Thank you for watching. So if you have any doubts, comment your doubts below. And if you like this video, make sure to leave a like on this video. And for more videos, subscribe to my YouTube channel. Thank you for watching.